All right, gang. Final video on confidence intervals, and this kind of puts it all together. And I just want to make sure that we're all on. Let me see if I can get something. Okay, see if we're all on board with what we got going on when we kind of throw all these in together and so on. So anyway, you can see I've attempted to try to teach you 3 types of confidence intervals. One is confidence interval for population proportion. These are the problems that report a percentage. I've also tried to teach you confidence intervals for a population mean when the value of the population standard deviation is known. And similarly speaking, population mean confidence interval estimating a population mean with a confidence interval when the population standard deviation is not known. And in this case, the standard deviation for the sample is known, or we can calculate it. So one of the keys, it's not going to be so critical on your homework assignment online, but it's going to be very critical when you're working your final exam, because these problems are going to be thrown in all together. So one of the things, the first hurdles is determining what type of confidence interval problem you're working, so you'll know which type of confidence interval key to hit. So so again, one of the keys is classify the problems correctly. So consider the following examples. IQ scores have a population standard deviation of 15. Assume that we wish to estimate the average. So guys, this tells me right here this is a mean problem. IQ for all students at Ohio State University. Since we have the population standard deviation known, this would be worked with the z-interval. Number 2, a large corporation would like to estimate the percentage of job applicants who fail their initial drug screening tests, dealing with the percentage. So guys, this is going to be a one prop z-interval. Number 3, a nutrition company would like to estimate the mean sodium. So guys, that word right there tells us we have a mu problem. For all reduced sodium hot dogs, the population standard deviation is not known, which tells us that we could calculate the sample standard deviation. So gang, we would calculate a t interval in that situation. So guys, going to work through each one of these. All right, so let's do it. So IQ scores have a population standard deviation of 15. Assume we wish to estimate the average IQ for students at Ohio State University. So obviously a large university, so it would be impossible to go out and test all of the students. So we collected a random sample of 32 students, get a sample mean of 115.25. What type? Guys, it's a z-interval because we're estimating a mean and the population standard deviation is known. So gang, we're just going to use the calculator here. One thing about this introductory statistics course is I'll allow you to make the calculations easily, and then it gives us more time to put in on interpretations. So gang, we're going to go down to z-interval because the population standard deviation is known. I have my statistical results. So the population standard deviation is 15. The sample mean is 115.25. The sample size was 32. And our confidence level is 0.95. So our interval runs from 110.05 up to 120.45. All right. Interpret in the context of the problem the meaning. There is a 0.95 probability. This interval contains mu, which is the mean IQ for all students at Ohio State University. All right. What is the margin of error? Big number minus small number divided by 2. Put a plus or minus in front. Assuming I didn't have any typos, I get 5.2. Now, sometimes I see people wanting to put a percentage sign there. Guys, this is not a percentage problem, so that's just silly. Don't do that. If we had constructed a 90% confidence interval instead of a 95% confidence interval, would the margin of error have been more or less or the same? Well, guys, clearly it would be less because we have less confidence. You know, again, I think I gave the example. If I was going to estimate the average age of students in my Math 1500 class, and I create confidence intervals from 0 to 100, well, I have gone so ridiculously wide that I could have a whole lot of confidence that that interval is going to contain the average age. But if I don't have much margin of error, then I can't have much confidence. So the smaller. And plus, if you think about it, the 1.95, your Z critical is 1.96. For the 90%, it's 1.645. Well, if you multiply by a smaller number, on the right side, you're going to get a smaller margin of error. So that should just be kind of commonsensical in a way. All right, gang. In a recent sample of 1,520 job applicants, 58 failed their initial drug screening test. We wish to use this information to estimate the percentage of all job applicants who failed their initial. So guys, we're trying to estimate a percentage here. So obviously we have a 1 prob Z interval that we're going to use. Use your calculator to find the 95% confidence interval. So guys, go stat. Again, these problems can be worked very quickly. For those of you that are impatient, like to work things fast, otherwise you get frustrated, these are good problems for you. So 58, 1520, I say that because I'm impatient. What do we want? 95%? So it looks like we're at about this right here, depending on how they ask you to enter your answer. I'm going to enter this as a percentage, so move this over 2 places. So it looks like we got 2.9% up to 4.8%. So guys, based on this result, this company can pretty reasonably predict that somewhere between about 3% and somewhere close to 5% of the job applicants will fail their initial drug screening test. Okay. Interpret in the context. Guys, I don't ask you to do the margin of error here, but I kind of always like, so 4.8 minus 2.9 divided by 2, looks like we get 0.95%. Now we do include the percentage there because it's a percentage problem. So there is a 0.95 probability. This interval contains P, which is the percentage of all job applicants who fail their drug test. That's pretty sad, isn't it? But what we do. It's the world we live in. Margin of error. Well, okay, I didn't realize that was down there. So Guys, put that down there. So margin of error is 0.95%. Gang, it's going to be the kind of video you like. It's going to be a short one. All right, example 3, a nutrition laboratory. Okay, that's weird. A nutrition laboratory tested 40 reduced sodium hot dogs from a certain company. The mean sodium content was 310 milligrams. The standard deviation for those 40 hot dogs was 36. But the fact that it tells us that it's the standard deviation for that specific sample tells us that the standard deviation was for the sample was 36, so SX. Plus, we have the added luxury here that says the population standard deviation is unknown, so sigma is not known. Well, guys, hopefully I've taught you enough by now that you know that's a classic case of a t-interval. All right. So use your calculator to find the 95% confidence interval. So let's do it. So I got a t-interval. Sample mean looks like it's 310. Sample standard deviation looks like it's 36. Sample size looks like there was 40 hot dogs. And what do we want? 95%? Yeah. So 298.49 up to 321.51. All right, so based on this estimate from these 40 hot dogs, it looks like that the population, or the mean for all of these hot dog brands, somewhere between 298 and 321. All right. Interpret, so there is a .95 probability. Now this interval contains mu, which is the mean sodium content for all hot dogs of this brand. I think these were what the brand was, low sodium, yeah, reduced sodium. So you could come in, it'd be equivalent to say all reduced sodium hot dogs, or you can say this brand. All right, gang, margin of error. Again, big number minus small number. Divided by 2. Okay, 321.51 minus 298.49 divided by 2, plus or minus 11.51. Guys, short video, just like we like them. I'm done. Take care.